A pleasant greetings to all students joining this particular tutorial session. Welcome or welcome back again to another video tutorial review lesson from the AP3X Institute of Applied Mathematics Education. My name is Akin, your math instructor, and in today's video tutorial, which is expected to be probably an hour long, I will be going through a recent exam structured paper, quiz number 2. If you guys have been subscribers on the channel from the inception, you would have seen where occasionally I will do tutorial videos on exam papers to which I have constructed, where I give my students exams like these on a tri-weekly basis in preparation for your exams, which is coming up in a few months. Of course, if this is the first time here on the channel, I do offer tutorial lessons primarily on the CSEC curriculum, but coming up in the future we will be also doing tutorial lessons for SATs, City and Guilds, EDXL exams. But for the most part, I primarily focus on the content related to the CSEC, CCSLC and the SEA exam questions. Alright, if this is the first time here on the channel, of course feel free to become a part of our family, where I post tutorial videos every week based on problem topics that students have. So be sure to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments down below. Let your video request or your topics be known, and if I am able to fulfill those requests within a convenient time frame for you, I will definitely be obliged to do so. All right, so that pretty much brings us into the objective for today. Oh yes, do not forget to hit the like button, guys. It really does help the channel to grow, and it helps the algorithm to get the math channel out there. All right, so I'm hoping to be with you here for maybe a little bit over an hour, and I'm going to be walking you through this particular paper here. This particular paper consists of, as you can see here on screen, the order of operations, fractions, a little bit of decimals. We're going to be introducing to you here measurement, perimeter and area, a little bit of percentage, introduction to algebra, variation, and so on, a little bit of ratio, and that should bring us to the end of this video. All right, please be sure to check out all the other useful tutorial lessons that are available on the channel, and of course let's just jump right into the lesson for today. So here we go. So for number 1 here, we are getting a startup marks here of dealing with the PEMDAS principle, and I've already marked the exam papers for my students for this particular exam, and I saw that there were a lot of little errors that were made that kind of cost them quite a bit of marks. And if you're one of my students in this current 2023 exam year, then you are definitely aware of the mistakes that you would have already made, because you would have already gotten back your exam paper. So let me just walk you through what should have been done for you to ace this exam paper here. Now, I've already written some of the questions here for you, so we're going to jump right into it here. The first one is in fact the PEMDAS that says 3 plus open bracket 14 divided by 7. Subtract negative 4 squared. So for this particular question, it was very simple for you to get the answer. It was in fact that you had to square the negative 4. Now what I find that a lot of my students did is that when they were using the calculator, they actually typed in negative 4 without the brackets, and that produced a result of negative 16. And some of the students, what they also did is that they tried to distribute the negative before the exponent. Remember, you're not allowed to multiply before you do the exponent. So for this particular problem here, then it was a requirement here that we say here. So we had to 3 plus open bracket 14 divided by 7 take away, and we had to square the negative 4. Now on the calculator, once you insert your brackets, you should get a positive 16, but of course it doesn't matter whether it's a negative number that is being squared or a positive number that is being squared, you're going to get a positive result. So once we've squared the 4, we should get a positive 16, but it lands in front of the negative sign, so it automatically makes it negative 16. Then we would therefore then close this bracket here and this one here. Next we'd move on to the division aspect. We're still within the parenthesis, so that's 3 plus 14 divided by 7 is in fact 2, take away 16, close the square bracket here. Next we have 3 plus 2 is equal to 5, take away 16, and that gives us a result of negative 11. That would have been our solution. Alright, so lots of little errors. If you have your paper in hand and you're watching this particular tutorial, look at your paper and you will see the error that you made. And so moving forward, I don't expect that you or any of my audience who is watching this video tutorial will make that error again. Alright, moving on to the second PEMDAS question here, where we have 56 divided by 3 cubes plus 1 minus 18 plus open bracket 8 times 3 minus 3. So once again we do brackets first. Lots of mistakes was also made in this one here, where a couple students made an error in terms of writing down 3 cubes. They wrote 3 times 3. So this is in fact 3 multiplied by 3 multiplied by 3. Please remember that the power tells us how many times the base multiplies itself. It is not the base times the power. So it is going to be 3 multiplied by 3 multiplied by 3, which is in fact 27 plus 1. Now we have to put this back in a bracket, because the only time the bracket disappears is when you get a single value for your answer. Now, of course, a few students left off the brackets and then they went ahead to divide the 56 by 27. That's going to give you an incorrect answer. Okay, minus 18 plus, then work out what is over here. 8 times 3 is 24. Okay, so we can actually go ahead and just write 24. Take away 3, and I'm choosing to do this in steps because of course my channel primarily based on helping students with your fundamental skills, and is not to show you exactly the shortest way to get the problem. Okay, I'm here to show you step by step how to get to your answer. Next then, that's 56 divided by 27 plus 1 is 28. Take away 18 plus 24 take away 3 is 21. Now all the brackets on the inside are gone. It's now time to operate according to PEMDAS. Division, subtraction, addition. We go ahead and we divide first. So that's going to be 2 take away 18 plus 21. Remember that with PEMDAS, when you have two tied operations or operations of preference, then with subtraction and addition, subtraction appears first, so it takes preference. 2 take away 18 is in fact negative 16 plus 21. And at this stage I found that also quite a few of my students were writing down negative 37, negative 39, various answers. Remember, this is coming from the integer video that I had posted. A link is in the description. If you're struggling with adding integers, you need to definitely check that tutorial out. Work on your fundamentals, guys, because it's going to be important for the future. So this is in fact going to be 5. All right, so that's going to be your answer. Remember that negative 16, you owe 21, you have pay what you owe, and you still have 20, and you still have 5 left over. So we're going to be moving on to this next question here, the fractions. That is 4 over 3 minus a half divided by 5 over 3 multiplied by 1 and 3 over 4. Now, I saw that also a couple students made an error in terms of cancelling when they were subtracting the fractions. I do also saw where some students were actually going against the complete rule of math, and they were taking away 1 from 4, 2 from 3, lots of different approaches to the question, and I particularly made this video just for those particular students who have been making these fundamental errors. All right, and of course, if you're an advanced student, definitely do not judge, because everybody learns differently. Some persons have gaps in their learning, and therefore it is my responsibility to help each and every student to fill those gaps. So as a reminder, check out the fraction video that I have on the channel. When you are subtracting or you're adding fractions, you must find the LCM. So here we'll go ahead and we'll find the LCM here, which is in fact 3 times 2 is 6. 3 into 6 goes 2 times, and 2 into 6 goes 3 times. Okay, 4 multiplied by 2 is 8, and 3 multiplied by 1 is 3. So therefore then we end up with this answer here to be 5 over 6 multiplied by 5 over 3. Oh, pardon me, not multiply, divided by 5 over 3 multiplied by, and we're going to do a conversion here. 4 times 1 is 4. 4 plus 3 is 7 over 4. So then, what do we end up with here is division and multiplication. Now, division and multiplication is more or less the same sort of operation. Now, I did find that a few of my students kind of went against PEMDAS, and they completely forgot that the division and multiplication are tied for preference. So therefore, whichever one comes first, do it first. I find that quite a few of my students tried to multiply before they divided, and that gave them an incorrect answer. So it's recommended that whichever operation comes first, do it first. Now, of course, with division, we know that this becomes 5 over 6. Division gets turned to multiplication, and we invert the last fraction. This becomes 3 over 5 multiplied by 7 over 4. The last fraction, meaning not the one at the end, but the one that immediately comes after the division sign, that's the one that we reciprocate. Therefore then, we end up with a straight multiplication problem. I did also find quite a few students finding LCM when they were multiplying. Be reminded, we do not find LCM when we are multiplying. We cancel terms. So I can cancel 5 with 5 here, goes 1 time, and I can cancel 3 into itself with the 6, goes 2 times. Doesn't seem as if anything is left over, so then therefore we have 1 times 7 is in fact 7, and 2 multiplied by 1 is 2 times 4 is 8. So we end up with an answer of 7 over 8. Alright, so that was a very easy way of doing the problem. Let me know if it is that you made that fundamental error, and of course we'll be able to talk in person. Alright, hit the like button, guys, if you're getting some value, if you've finally understood where you're actually making the mistake. Leave your thoughts and comments down into the comment section below. Let's jump right into the next question here. So this particular question here requires us to work the problem in parts. And so what we end up with here is, say, the top part followed by the bottom part. Now I did make an error typing the question. I didn't see until when a student pointed it out. I wanted this to be 3/5, but I made a typing error and I got 3/3. Nevertheless, at the point where the student had pointed out that that could be an error in terms of my typing, I just allowed the question to go on and we just evaluate as is. But here we go. Let's do some conversion then. 2 multiplied by 1 is 2 plus 1 is in fact 3/2. Take away 2/5. Okay, and then at the bottom I'm just doing all my conversion. I kind of prefer doing that first. Okay, at the bottom then you'll see where I stated that this was an error, but nevertheless, let's cancel this out. We end up with 1/1, which is in fact 1, and with the multiplication of any number times 1 will obviously give us the same number here. So we'll end up with what is at the bottom here is 5 times 4 is 20. 20 plus 2 is 22/5. Next then, we're going to move on then to say here, working out the top section of the problem. So let's bring this down here. That's 3/2. We're taking the top part of the problem and bringing it to the side here to work it out. So we are subtracting. We're going to go ahead and find the LCM. Okay, so the LCM here is 10. 2 into 10, 5 times, and 5 into 10, say here, 2 times. 3 times 5 is 15, and 2 times 2 is 4. So we end up here with 11/10. Okay, so then therefore that's the answer for the top. We have 11/10. Then we're going to be dividing this by 22/5. Therefore then 11/10 division becomes multiplication, and the last fraction is inverted to become 5/22. Therefore then we can do some cancellation. 5 into itself 1 time, 5 into 10 2. Remember, we cancel whenever we are multiplying fractions. 11 into itself 1 time, 11 into 22 2 times. So we end up with a really nice easy result here of 1 times 1 is 1 and 2 times 2 is 4. You end up with 1/4 as your solution. All right, so then we move on next to then the decimal aspect of the problem. And again, I found that quite a few students made a huge error by subtracting before they divided or even work out the exponent. Quite a few. I saw probably about 20% of my classes, or not say 20%, say about 10% of the students, they subtracted the 1.7 from the 8.54. You're not allowed to subtract before you even divide or do exponent. So what was required here for this question is to say here 8.4 minus 1.7 divided by the square of 0.07. Once you square that, you can see that the answer is 0.0049. Now, when you divide 1.7 by 0.0049, you should end up with a result here of 346.93. 346.93. And then after subtracting this, your answer here is going to be negative 338.39. Negative 338.39. All right, so we get a negative answer. Now on the paper, I believe I had made an error. I don't think I calculated this when I was doing the answer, but I had asked them for 3 decimal places and 5 significant figures. So if it was perhaps say here 3 decimal places, then if that's what we were required to find, then 3 decimal places, I would have needed more digits at the end. So I had just simply omitted that instruction part of the question and gave you all full marks for this answer. All right, so that's the answer that I was looking for. Now for this question here, I find that quite a few of my students seem to not understand how to actually insert a fraction as a power on the calculator. Now here I'm going to put a screenshot. I'm going to put a overlay video here of what to type in on the calculator. Here we go. So then you would have gone ahead to type 0.4. If you're using a phone as your calculator, then you may have to use the brackets on the calculator. But if you're using a regular calculator, then you could insert here the button that looks like this. So once you've typed in 0.4, press this button here, or you press this button here, X to the Y, insert, open your bracket, 2 divided by 5, or you could type in 0.4, then you should end up with a result of, say here, the square root of 0.693 plus, you're going to go ahead then and you're going to cos 54 degrees. That should give you 0.587. Now once you go ahead then and you find the sum of these two numbers, you should end up with a result of square root of, say here, 1.280. And completing this then, the square root of 1.280 is in fact 1.1317, and that would have been your answer. Now to 3 decimal places, that would have been 1.132. If it was 5 significant figures, it would just be as it is here for 5 significant figures. All right, so that wasn't really a tough question. I found that probably 45% of my class got this question incorrect. Not sure, I believe this was the issue. So you guys definitely need to get used to using the calculator in raising numbers to fractional powers. All right, so that pretty much wraps up that particular question there. All right, so we're off to a pretty good start. You would have already seen a couple of mistakes that you've made here, and then we are going to go right ahead then and we are going to move on to question number 2. Now the diagram for this particular question here was drawn on the board, so I'm going to draw it for you, my audience, who was not a part of this particular quiz. And so the triangle that was given to them had a distance here, or had a length of 14.5. It also had a length of 11 point, I believe it was 4, and I believe this was 4.7, all in centimeter. All right, now one of my other groups, they didn't reach this particular topic, so I had given them another question to replace this one, which I'm not going to be going through in this particular video, but hopefully it comes up in another tutorial. All right, but this was the particular question that majority of the students got. Now I did provide them with the formula, and so if you all remember the discussion that we had, I'm definitely going to be putting out a tutorial on knowing what formulas to use when solving for the areas of different triangles. So be sure to hit the subscribe button below so you can be notified whenever that video comes out. Here we have to use what is known as the Heron's formula. So the Heron's formula, let's go to a blank page here. And so the Heron's formula, let's redraw our diagram here. So by redrawing our diagram, we end up with, say here, this. And let's insert 14.5. I believe this was 11.7. Oh, this is 11.4. And 4.7. I believe that's what it was. Okay, let me just double check on that. Yes, that's what it was. 11.4, 4.7, 14.5. So therefore then, we needed to use the Heron's formula. And so for the Heron's formula, there are two parts. We needed to find the value of S, which is known as the semi-perimeter, which means that we are going to need to add up all the sides and divide by 2. Then once we've attained the value for S, we then need to transfer it to the main formula that states that the area is equal to the square root of the semi-perimeter multiplied by the semi-perimeter minus each of the lengths. That is the Heron's formula. So we need to proceed to find S. S would then have been 4.7 plus 11.4 plus 14.5 divided by 2. And another fundamental error, especially when it comes to using the calculator, I find that a few, not a lot, but a few of my students got the semi-perimeter incorrect, pardon me, when they actually typed in everything on the calculator at once. And when you do that, the calculator is going to divide the last number by 2, then it's going to add the 4.7 and the 11.4. So what you needed to do was insert the sum of the sides, press equal, then divide the result by 2. You should end up with 15.3. A few of my students end up with answers like 24.4 and some sort of different answers. So be careful, guys, when you're using your calculator. All right, you have to manipulate the problem. Okay, then next we're going to move on then to inserting here. And quite a few of my students also froze, where once given the opportunity to use this formula, they completely forgot to use S. The formula states that S, which is what we just calculated, is going to multiply S again, which is 15.3, take away A, which is 4.7, multiply then again by 15.3, because that is S again right here, take away B, which is 11.4. Once again, extending our square root here, we have S once more, which is 15.3, take away 14.5. Of course then, once we have completed that, we should end up with 15.3. So we end up with square root of 15.3 multiplied by, let me see here, 4.7. I believe that gives me 10.6 multiplied by, say here, 3.9 multiplied by 0.8. all right, then we'd move on next to continuing finding the square root of the product of these four numbers. And the product of these four numbers turned out to be exactly 506 point some decimal places, I believe. So it's 00. So I've just written 506 exactly. And then going on the calculator, finding the square root of 506 gives you 22.49 squared centimeters. And that gives you the area of that particular triangle. So hopefully you guys would have been looking at your paper. If you attempted the question, you would have seen where you made the error, And if you didn't attempt the question, then of course you now know next time what needs to be done. All right, so that takes care of that particular question. Let's go back to the main page here and look at what we have next to do. Now, this was a very interesting question here, and this was for me an applied question. And I also find, and as I said, whenever I do my tutorial videos, it is mainly reteaching my content. So I'm using the opportunity with these exam papers to highlight errors that many, believe it or not, many students make these errors. And so we want to be able to identify the errors that we're making, and so moving forward we're not able to, or we're not going to be making these errors again. All right, so here we are given, it states that given that the area of a circle is 254 square centimeters, determine the perimeter of the circle. And what I find though is that quite a few of my students really didn't know where to start. It was a little bit discombobulating, but it was a little bit scary when they stated to me that they didn't really know where to start. So I've been using this technique where I've been teaching students how to use keywords to guide them into what should be written down first. And so when you get a question like this, you have to be able to know what formula is going to bring you to your answer. And the mere fact that you saw the word area and you saw the word circle, then that simply means that the very first thing needed to be written down on paper here was in fact A equals pi r squared. It is from here that then you're going to proceed into what needs to be done. Now, reading the question, you'll see clearly where it states that the area of the circle is 254. So you needed to put the 254 beneath the variable a. The centimeters squared is only for recognition purposes. It is only to state that the unit of measurement for area is squared units. It is not a part of your calculation. I find quite a bit of my students squaring the 254 and getting a humongous number. But of course, we now know that our focus should be on the value and not on the unit of measurement. We're going to go ahead then and we're going to equate that to pi the constant, which is 3.142, or some students who are watching from somewhere else would know that pi is 3.14 or 22/7. We can use both. Obviously then we weren't given the radius, so we definitely will need to find the radius, because to find the perimeter, which is another keyword in the question here, we'll need to evoke the formula C equal 2 pi r. So we don't have r, so we are not able to find the circumference. So we're going to have to find r and transfer the value of r to this formula over here to complete the circumference then. So then 254 is equated to, okay, let's not do that. Let's go right ahead here and remove the coefficient pi. Let's go ahead here and remove the coefficient pi. On your calculator, for those who may need a bit of advanced knowledge, there is a button on your calculator that represents pi. I believe it's at the bottom right side of your calculator. If you have a calculator in hand, then look at the bottom of the calculator. You should see right above the button. I'm not quite sure what button it's on, but at the bottom of the calculator, you should see on the surface of the calculator the symbol pi. So if you can press the shift button or the second function button that's to the top left hand side of your calculator and press the button that has the pi symbol over it, then that will give you an accurate answer for pi. Nevertheless, you can just go right ahead here and divide this here by, say, 3.142, and that will give you r squared. Okay, So if we divide 3.142, sorry, if we divide 254 by 3.14 or 3.142, you should get an approximate answer of 80.89. So r squared is equal to 80.89. Now I also did find, and I have to mention these little errors that my students made, and I really do hope that this video is really helping you guys not to make these fundamental errors in the future. Squaring removes the square root, and square rooting removes the square. So we need to isolate r. We need to remove the power of 2 from the r. So that means we're going to be square rooting the r squared. So by square rooting the r squared, you're going to find here that we have to also square root this side over here. So by square rooting here, we get 80.89. Then the square root will cancel the square on the r. So we're left with a value here of r is equal to 8.99. All right. And that pretty much gives us the radius of r. Now by transferring the radius of r to the circumference formula, because of course it says determine the perimeter of the circle, then you will find here that c equals 2 multiplied by 3.142 multiplied by 8.99. So then you find here that c is equal to, when we multiply all of that value there, we end up with 56.48. So that really is how you should approach this particular question here. Okay, by finding, say here, the radius from the area formula, because that's what we were given as a starting point. Then by transferring the radius value to the circumference formula, we end up calculating the circumference of the circle. All right. Now I didn't actually do this on a separate page, so I want you guys to take a screenshot of what is here, because I'm going to be removing this here to create space for the other questions. All right. So assuming that you have already taken your screenshot here, let's make a note that our circumference is 56.48 and our radius is 8.99. Let's make a note of that. All right, so here, let's make a note here that the radius is 8.99 and the circumference is 56, say here, 0.48. Let's make a note of that. All right, now moving on then, it says here then that the circle was then bent to form a, let's go here. It was bent to form a rectangle with its width of 19.4. We are to determine the length of the rectangle. All right, so this is an applied question. Okay, so then let's use our imagination. Here we have is, let's go to a blank page. All right, so let's use our imagination. Say we have here, say, a circle, and we have already established that the circle has a distance around it to be, say here, 56.48. Please note that the radius is in fact 8.99. So let's imagine us taking this circle and reforming the circle to form a rectangle. So basically this particular edge here, let's highlight it, this edge here was then reformed, and then we take all this edge around here to form this particular shape, okay, all the way around here. And we are told that the length is in fact 19.4. So we know here that is 19.4. And with the properties of a rectangle, we know that opposite sides are equal. So that down here also means that that is 19.4 centimeter. So we know that for sure. All right. So in other words, then we are saying that the circumference of the circle is in fact the same thing as the perimeter of the rectangle, because the same edge, or the distance of the edge, which is the distance around the circle, was what was used to create this particular rectangle. But we know that the length of the rectangle is 19.4 according to the question. So what that means for us then is that if we can add these two lengths here, say here we have the total length is 56.48, we can subtract what we know about the rectangle. So that's going to be 19.4 multiplied by 2, because we want to subtract this here two lengths, or the sum of these two lengths. So by doing that, say here we end up with 38.8. So that's 56.48 subtract 38.8. So that results here for us 17.6. So this 17.6 centimeter is pretty much the sum of these two sides here and here. Now, due to the fact that it's a rectangle and the opposite sides are equal, then if we have the sum of this side and they are both equal, we can safely say by logical reasoning that 17.6 then divided by 2 will give us the length of those other two sides. And so mathematically, then it works out to be 8.84 centimeters. All right, and that is what was required to actually get this particular question. And this is definitely an exam structured type question that you guys definitely need to wrap your minds around. All right, because this is how CSEC tends to structure its question, or sometimes even a little bit more challenging than this. So get used to the idea of doing this kind of arithmetic here, transfer learning. Okay, all right, wonderful. So then that completes that particular problem. All right, so then we're going to move on then to question, say here 3 all the way up here. And so we're moving on to variation, direct and inverse. And so I chose this setup for the question because, of course, I wanted to catch my students off guard by using this sort of analogy here, using the area of a circle to see if they could actually pick out that it's not necessarily that I want them to calculate the area of the circle, but I've created a relationship between the area of the circle and its radius using variation. Now, if you pay close attention to the question, you'll realize that one particular word stands out here. It is in bold. Varies. That's the key word to let you know that regardless of the relationship between the variables or whatever it is that we are creating a relationship with, this still boils down to the fact that it's a variation problem, all right, or a proportion problem. So then let's see if we can find some empty space here. There's nothing here for us. Let's go on a blank page here. But before we go on the blank page, let's take note of a few values of the variables. Now, in my direct variation videos, you would have seen, and if you haven't checked that out, it is definitely a very detailed explanation video. You want to definitely go ahead and check that video out for a complete review on variation and proportion. A link will be in the description, or you can simply check on the playlist on the top of my YouTube page. Here we go. It says then that given that the area of a circle varies directly as the cube of its radius. If the area is 64 and the radius is 2, we are to go ahead and answer the following questions here. Now, the mere fact that the question uses the word varies and it also uses the word directly, then this calls to mind that we need to utilize the formula or the standard formula. Say here, y equals k multiplied by x. That's the standardized formula. Now, we are in fact comparing area, say here, with radius. So since as y varies directly as x in a standard form, in this particular question here, area varies directly as the cube of its radius. I find that quite a few of my students, they got the whole entire problem incorrect because they failed to write the correct relationship between the variables. So if you're looking at your paper and you didn't write down this particular formula here that I'm going to highlight here in red, then that would have been the contributor to why you did not get full marks. This is the relationship. Area varies directly as the cube of its radius. The radius must be cubed. Now, of course, in the tutorial, complete tutorial guide, again, as I said, a link is in the description box below. It stated that you must always be given two values to obtain the value of k. And on paper here, you see clearly where I stated that the area is in fact 64 and the radius is 2. Now using that information, then we can go right ahead then and we can safely say then that area is 64. That goes underneath A. Obviously k is unknown and the radius here is 2, but we have to cube it. Okay, so then if you're successful in doing that, you will find here that 64 is equal to k multiplied by 2 times 2 times 2 is 8. So therefore then, dividing both sides by 8, as we had said before, to remove the coefficient from in front of a variable, k then works out here to be 8. Alright, so then now that we have calculated the value of k, we then need to rewrite our formula. And then so far we have a is equal to k multiplied by r cube. Now that we have established the value of k, let's see what else it is that they're asking us to calculate here. They're then saying then that we should find the area of the circle if the radius is in fact 12.5. So then find the area if the radius is in fact 12.5. So area then is equal to k, which is 8, multiplied by radius here, which is 12.5, and quite a few students forgot to cube the 12.5. So then of course, by cubing the 12.5 here, we're going to end up with 1553.12. So that is a equals 8 multiplied by 1953.12, and so therefore a works out here to be 15,625. All right, and based on the relationship that was created between the radius and the area of this particular circle, then it works out that the area is 15,625 squared centimeters. Now, it's strongly recommended that once you're doing a variation question, you always need to rewrite your formula once you're going to be doing something else then. So then we have to rewrite our formula as a equal k multiplied by r cube. And so therefore the question then goes on to ask us for the last part here for finding the radius then if the area is 196. Finding the radius if the area is equal to 196. So then what we have here is 196, which is the indicated value for area. K is actually equal to 8, and then we're going to be multiplying that then by r cubed, which is what we're looking for. So just like before, to isolate the r cube, we're going to divide both sides by 8. And so we're dividing 196 by 8. We end up with a solution here of 24.5. So we end up with r cube being equal to 24.5. And earlier we had, when I asked you to take the screenshot of that question, we said that squaring removes square root and square root removes squaring. It is quite similar that in fact cube rooting removes the cube, and cubing and cube removes the cube root. So here we're trying to remove the cube that is attached itself to the r. So we're going to be cube rooting, of course, the right side, and cube rooting, of course, the left side, which is 24.5. So the cube root here will in fact cancel this cube. So r then works out here to be 2.90. All right. And that pretty much wraps up that particular direct variation adjusted equation. Okay then. So moving on to the next question. The next question here is in fact an inverse variation relationship, but you were given the question here in the form of a table. And so when the question is given in the form of a table, then of course the first thing we need to do is to determine what is the relationship between the variables. It is in fact a inverse variation relationship, and so the relationship is not between y and x. The relationship is between d and s. So if we go across here and we write down our standardized formula, then y equal k over x, by adjusting the formula, then you'll realize then that we have converted the y to becoming the distance. K remains on top as the constant of proportionality or the constant of variation. And in the question here, you'll see clearly where they said that it is inversely as the square root of s square root. Quite a few students on this particular exam paper, they wrote quite different variances. I saw a few d squared equal to k over s. I saw s squared equal k over d. I saw d equal k over s. I didn't actually see the correct variation formula. And so it's very important that when you get variation questions, you have to first, in my opinion, as a fundamental student, I would recommend that you write down the standardized relationship as what you would have been accustomed to, which is y varies directly or inversely as x. Then you make the comparison between the variables. And so you'll see that distance is inversely, which is division, as the square root of s. And so this is what our standardized formula will be like. So here then, now we're looking for finding k. So therefore then, on the table, you would have been given two values. Whenever you get a table, sometimes the two known values are in the middle, sometimes it's at the end, and like this example, it's at the beginning. Now, we can't use the 27 because we don't know what the value of d is here. And we can't use the 4 because we don't know what the value of s is here. But we know what the value of d and s is in this column. So these two values here are going to be useful for us to finding the mandatory value of k. So in this case here, we are told then that d is in fact 2. So 2, that's going to be the d up here. That's going to be equated then to k, which is unknown, divided by the square root of the speed, which in this case is 36. Now naturally then by finding the square root of 36, we'll find here that the answer is 6. And of course, when the unknown variable is at the top, we're simply going to cross multiply. So that's 2 multiplied by 6. K works out nicely here to be 12. 2 marks just to attain the value of k. You notice here that I've already written down my formula or rewritten my formula 2 more times. Why? Because I know that the next question then is going to ask me for either D or S, because I've just calculated K. So here you'll see that there's an empty space in the column or in the row that's across from D. So in this case here, we're looking for the value of D, while S is 27. So therefore then, going across our formula, D is in fact unknown, K was just calculated to be 12, and S based on the table is in fact 27. So that becomes the square root of 27. D then works out to 12 divided by the square root of 27 is in fact 5.196, and by dividing 12 by 5.196, it works out that D is in fact 2.31. Now upon constructing this paper, which is something that I always do, I don't swat practice questions from past papers. I think that there's a limitation to that. Past questions are past questions for a reason. I do believe that structuring questions will give students a more widespread opportunity to open their brains to the possibility of what other questions can look like. So I always structure my own practice papers. So then, what are we looking at? The third part of this question here is looking to find the missing value. Let's put our value here, 2.31. Here we're looking for this empty space here, which is across from S. So S is what's missing, while D is in fact 4. So D is 4 right here. K was calculated to be 12, and then we're in fact looking for S. But S is therefore stuck underneath the square root of D. Now before we can do that, let's first recall that if the unknown variable is at the bottom of the equation or the bottom of the fraction, or if it's the denominator, then we're going to be doing a swap. We're going to be swapping the position of the 4 with the square root of S, and swapping the square root of X with with 4. So then the square root of S then is equal to 3. And as at this stage here, where my students didn't acquire full marks because quite a few students went ahead to find the square root of 3. Be reminded that to remove the square root from a variable, or just in fact to remove the square root that is covering a value or a variable, preferably a variable, then we're going to be using the opposite or the corresponding power. So this is a square root. We're going to be squaring both sides. What do I mean by squaring both sides? I'm going to be squaring the square root of S, and I'm going to be squaring the 3. So then what I'll end up here with is in fact the square root is being cancelled by the square. So I've now isolated S, and then 3 squared is 9. Quite a few of my students lost a few marks here by square rooting the 3, which gave them 1.73, which they have lost some marks there. All right, but you've seen it, you've seen where you went wrong, and so going forward, I do hope that you are able to then not make these fundamental mistakes. All right, remember that you guys are being prematurely exposed to some concepts that you would have been that you would have seen a while back, you would have seen back in high school where you didn't pay much attention to what was being taught. So remember that if you are that type of student who is learning under this crash course teaching that I do on a yearly basis, there's going to be some gaps in your learning which you're going to have to take the time out to fill by doing more work than the average student who is at school on a daily basis. All right, moving on next to this particular problem that shocked me when my students gave me the result. A lot of students confused the rules of adding and subtracting with the rules of multiplication and division. And so do check out the tutorial video that I have on addition and subtraction of algebraic expressions, and in part 2 I did multiplication and division of algebraic expressions. If you are a serious student who finds algebra a little bit challenging, you've got to take the time out to work out and evaluate the fundamental skill set that you need to be able to survive the concept of algebra. All right, so you have to take the time out to clear up those problems before you take on bigger algebra problems. All right, now as a reiteration, remember that when we are adding and or subtracting algebraic expressions, the focus is going to be on the coefficients here, 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 and in fact here. That's where the focus is going to be on. And in fact, remember that we have to group like terms. Now, when you are actually multiplying and dividing, then the focus will then shift not so much on the coefficient, but the focus is going to be shift towards the powers here, 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 and here. That's where the focus is going to be shift. Quite a few students applied the multiplication and division rules to addition and subtraction, and that cost you quite a few marks. But in this tutorial, we're going to clear up all those ambiguities, all those misconceptions, misunderstanding. So for this particular question here, all that is required for you is to group the terms that are alike. We're going to be using colors here. All right. So I'm going to be grouping, and I'm going to be trying to find a term that has an x squared y. And so if you look all the way out here, you realize that this term and this term are alike. So we group them together. And as I had explained in my tutorial video, I also find a few students bringing this sign down and moving this 7x squared y here. So they end up with 3x squared y minus 7x squared y. Remember that rearrangement of the term will not change your sign. You have to rearrange the term but bring the sign that is in front of the term with the term. All right, so students, a couple of students may have gotten -4 for their answer, and they would have gotten that incorrect simply because you have a minus sign instead of a plus sign. Next, we're going to be looking for, say here, the term that has xy squared. So this is minus 2xy squared minus, I forgot the square here, minus 8xy squared. Then we have this odd term out here. He has no one to be grouped with, so it's just going to be left as 7xy. All right, so then we're going to be adding the coefficients. The bases or the variables, composite or monomial, does not affect the calculation. It is just the coefficients. So 3 plus 7 is in fact 10x squared y. And again, I find that a couple students are in fact still making this fundamental error of ignoring the sign that is in front of the number. A couple students worked this out and they got -6 because they are ignoring the sign that is in front of the negative, in front of the 2. So this is in fact negative 2 minus 8, which is negative 10xy squared. Remember, like signs, you're going to keep the same sign and add both numbers. Please feel free to visit my operations with integer tutorial. You'll see a thumbnail screenshot on screen at the moment talking about that particular tutorial. So check that tutorial out, guys, if you are not comfortable with adding numbers. Remember that in algebra, you won't be able to use your calculator as much. All right. Then we bring down this 7xy, and that is it. There's nothing more that we can do because all the terms are in fact unlike. All right. So therefore then, that's what we are in fact looking at. Next, we're going to be moving on to working out 24 a squared b plus 7x squared y. I'm so sorry, made an error. That's going to be 24 a squared b divided by 6 a to the 4 b to the minus 2, and that's going to be multiplied by 3a to the minus 1 b to the 5. And it was so funny that most of my students actually got this question correct. Yes, they did make 1 or 2 mistakes with the sign, but for the most part they actually went through the process and got very close to the answer. Made an error with 1 or 2 of the powers, but they acquired some marks for the steps. So with this particular part of the quiz is that you guys applied the multiplication rule, the multiplication and division rule to the addition and subtraction rule. Now you're going to be seeing the difference. Now, as mentioned before, that when you're dividing and multiplying, the focus has now been shifted from not just the coefficients, but it's now going to be shifted to the power. Because when you're multiplying and the bases are the same, you're going to be adding the powers, and when you're dividing, you are going to be subtracting the powers. Now, what I taught my students to do fundamentally, you're going to be taking out the numbers. 24 divided by 6 multiplied by 3. Again, if you're an advanced or intermediate level student, you can always go ahead and do the calculation for all the coefficients and rewrite your answer as 12. But I recommend that as a student who is either doing this for the first time or you're finally getting a hang of algebra, take your time and go through the process and write down what is necessary. Quite a few students, I'm not sure if it's a problem that they have or it's a nonchalant attitude where they do not really want to write stuff down. Remember that when the powers are negative and positive, you may end up with signs clashing. And so when signs clash, sometimes when it looks as if you're supposed to subtract, you end up adding, and when you're supposed to add, you end up subtracting. So it's recommended by me here, Akin, that you write down your powers. Okay? Mentally, if you're able to do it without making a mistake, then I strongly recommend that you do. If not, you do this. You rewrite the base. Well, let's gather all the a's together first. So we have a squared divided by, say here, a4 multiplied here by a to the minus 1. Join that with b. Notice there is no power. So the power, well, there's no obvious power or indicated power. So the power here is understood to be 1. That's going to be divided then by b here to be minus 2. And that's going to be multiplied then by b to the positive 5. I think it's negative 5. I think it is negative 5. Let's double check on that, guys. I think it is negative 5, or is it positive 5? It is actually negative 5 as I'm seeing it here. Okay, so it is in fact negative 5. Alright, so it is negative 5. So now then, 24 divided by 6 is 4, and 4 times 3 is in fact 12. This is A. Okay, that is A. So notice now that between these two A's, I'm dividing. So that's now telling me that I need to subtract the power of 4 from the power of 2. And then as I continue, I now realize that I'm multiplying, so I'm going to be adding the power of minus 1. Okay, so I'm subtracting these two powers and then adding the negative 1 to it. I move on to the B section here, which is now 1. I'm dividing, so I'm going to be subtracting negative 2, and then I'm going to be adding negative 5. And earlier, as I said, that you will end up with sign clashes like what we're looking at here, and you have to be very careful because it only takes one missed sign or a sign that you fail to write down that will produce a result that goes against the correct answer. So here we end up with 12A, and notice here that this is 2 take away 4 unlike signs. So 2 take away 4 is negative 2. So these 2 is negative 2, and then here this positive and this negative becomes a negative. So we end up with negative 2. So this is negative 2 here minus 1, which works out to be negative 3. B here, negative times negative here becomes a positive. So you end up with 1 plus 2, which is 3. So now we end up with 3 here plus negative 5. And so these are unlike signs. So we take the smaller number, which is 3, away from the larger number, which is 5. So that is 2. But the sign of the larger number is negative. So it becomes negative 2. Alright? So you need to definitely work on that. I do not have a video out as yet about sign clashes, but it's not a very difficult thing to do. You just have to remember that the rules are a negative brackets or multiplies a negative gives a positive, and a positive multiplies a negative gives a negative, and sort out the clashes and evaluate. Alright, so that takes care of that particular problem. I do hope that going forward, again guys, as I said, you're not going to be making the mix up with adding and subtracting compared to that of multiplying and dividing. Now, my students have yet to reach ratio. We are approaching that topic. So as I'm doing this topic here, you're going to be prematurely exposed to something that's coming up. Alright, but for the remaining audience here, wherever you're watching from, ratio could be a problem that you have, and we are about to attack a problem on ratio. So here what we're looking at then is in fact a sum of money is to be shared among 3 friends, Romali, Daniela, and Shakira, in the ratio 4 to 7 to 13. And it so happens that these are 3 names of 3 of my favorite students in my class as we speak: Romali, Daniela, and Shakira. Alright, so how do we approach this then? It says here that Shakira received $420.50 more than Romali. What I actually should have written as I was actually working through the paper, I actually wanted to write that Daniela received $420.50 more than Romali, but nevertheless, regardless of whatever it is, we are going to be evaluating the problem. So then there, First thing that they ask us here is to determine the sum of money that was shared among three friends. Now, in ratio, there is a rule, there's three-step process in evaluating any ratio problem. And so coming up, guys, you're going to learn that when it comes to ratio, the first thing that we want to do is to write down the comparative quantities. Who are the persons involved in this particular ratio? So here we're looking at the fact that Romali is being compared to Daniela, who is then being compared to Shakira. And the ratio between the three students is in fact 4 to 7 to 13. So obviously, by those numbers, Shakira would have gotten most of the money that was shared. Now, it was stated here that Shakira got $420.50 more than Romali. So why is it that Shakira got $420 more than Romali? It is obvious that because Shakira got more shares than Romali. So our task here is to find out the difference between the shares of the student. So the difference is going to be 13 take away 4. So Shakira would have gotten 9 shares more than Romali, which is the exact reason why Shakira has received $420.50 more than Romali. So then, once we have calculated that Shakira has gotten more, then what we're looking at then is, since 9 shares, which is the difference, equates to 420.50, then 1 share, which is again direct proportion here, 1 share is going to be equal to 420.50 divided by 9. So on my answer sheet, I made an error, so I have to recalculate with you guys. This is looking like 420.50 divided by 9. This works out to be $46.72. That's 1 share. Now the question did ask us for how much money was being shared. Well, we know that for certain that the total shares is 4 plus 7 plus 13, which works out naturally here to be 24. So if 1 share is equal to 46.72 and we have a total share of 24, then the total sum is then equal to 24 multiplied by the value of 1 share, 46.72. So if we multiply that by 24, we should get a total sum of money that was shared to be $1,121.33. That's how much money was being shared between the 3 students. The question went on next to ask us to express Daniela's share as a percentage of the total. So we need to calculate what's Daniela's percentage amount. There's actually 2 ways we can evaluate this particular problem. We can calculate by means of using the shares, or we can actually calculate Daniela's amount of money and compare it to the total that is currently being shared. So the shortest way here is to take Daniela's share. So let's write it down. Daniela's percentage equates to 7 divided by 24, and we're going to multiply that by 100. That's the shortest way to do it. So 7 divided by 24 multiplied by 100. Daniela basically would have gotten 29% of the money. Or alternatively, we can simply calculate Daniela's share, which is going to be 7 multiplied by one share, which is 46.72. That will give us the exact amount of money that Daniela received. So 7 multiplied by 46.72. Daniela would have gotten exactly $372.04. So then to express Daniela's money as a percentage, we would then divide the amount that she received by the total that was shared, which we just calculated to be 1,121.33, alternatively multiplied by 100. So then therefore, if we do the math on that, then you find out that you get the same answer of 29%. So as I always tell my student, pick your poison, choose the method that best suits you. All right, and then moving on to say here, this last part here, state the amount received by Romali. Then the amount received by Romali is simply going to be the amount of shares that Romali got, which is in fact 4 multiplied by the value of one share, which is going to be 46.72. And so therefore 46.72 multiplied by 4 tells us that Romali would have gotten $186.88. All right, so that is how you would have actually calculated the ratio and proportion. All right, now if you're watching this, you are prematurely being exposed to the ratio, which is coming up in this week's class. So if you're watching this video, you're already ahead in the class. All right, so that is how you approach that. And let's just wrap this video up and bring us to the end of this tutorial by solving this final question at the bottom. Again guys, if you are in fact enjoying the explanation and you're finally clearing up, you're now seeing where you would have made the error, then therefore hit that like button. Last question here, I should be able to do it right here on the screen for you. A man bought, and this was a typing error here, a man bought 45 t-shirts at a cost of $5,250 and he wishes to make a 35% profit on the sales of the shirt. Calculate how much should he sell each shirt for. There is a unitary method and there is an alternative method to getting this answer, which I'm going to be showing you, bring us to the end of this video. So first, traditionally, I would think that I wanted to find out how much profit is this man intend on making. So I can safely percentage the amount here. So I can simply say here 35%. Pardon me guys. So I can simply say here 35% over 100 and multiply it by the cost that he paid for the 45 shirts. That should therefore then give me a total here. I think I'm looking at my answer sheet and I did the alternative method. So let's double calculate here. 35 divided by 100 multiplied by 5,250. That gives me $1,837.50. So that's the man's intended profit. Now, since we're going to be adding on, the man is going to receive the money that he spent along with the profit. So we should go ahead then and add, say here, the 5,250 to the intended profit, which is 1,837.50. And that should give me a total of $7,087. So that's $7,087.50. Now that would be the amount of money that he's intending on collecting after selling all 45 shirts. So I could therefore go ahead then to calculate the cost of one shirt. I would therefore then divide the 7,087.50 by 45, and then that should give me the value of, say here, one shirt, which is $157.50. That is if you see the problem in that way. All right, take a screenshot of that. Alternatively then, we could simply go ahead then and find out how much did he pay for one shirt. How much did he pay for one shirt? So since he spent $5,250 on, say here, one shirt, if we divide this by 45, this would tell us the cost that he paid for one shirt. So 5,250 divided by 45, that tells us that he paid $116.66 for one shirt. We can therefore alternatively find the percentage amount that will be added to the cost of the shirt. So that's 35% over 100 multiplied by $116.66. And if I remember the math correctly, then this here is going to be, pardon me, so 35 divided by 100 multiplied by 116.16. that gives me a intended profit on one shirt to be $40.66. That's what's going to be added on to one shirt. So by adding on what he spent for one shirt plus the intended profit from one shirt, then that's 116.66 plus 40.66. That tells me that I'm going to get an answer of 157. Well, I'm getting 156.81 because I did some rounding off, but it's more or less within the margin of error. So I'm getting $156 and, say here, 81 cents. All right, so if we didn't round off, if we used the exact value, we would have gotten relatively the same answer. All right, so that is how you would have attained 100% on this particular quiz. I do hope that the particular quiz here was useful to you, and I hope that going forward you have learned a lot from your mistakes. So as the next quiz is coming up, which will involve majority of what you are doing now plus more, then looking forward to seeing better grades. All right, thank you so much for watching, whether you are in my class or you're just watching here on YouTube for preparation purposes. Thank you so much for watching. Leave a like, leave a comment, leave your video request, and of course do not forget to subscribe and turn on the bell notification. So until next time, my name is Akin, and I'll see you in another tutorial video. Take care. Bye bye.